Okay guys, good morning, hello. What I've got here is an example of linear programming, finding an optimal solution with integer solutions allowed only. So what I've got here in this samplet that I created is the example on page 178 at the bottom, example 11. So what we've got here is in the axis, xy axis, I've got equations 1, 2, equation 3, equation 4 are the constraints that we have in our optimization problem. Our objective function p is x plus 2y, and then as you can see from page 178 we have 1, 2, 3, 4 equations, 4 constraints, plus an extra constraint, which is y being greater than or equal to 2, which is the horizontal line there. Okay, now just from looking at it, you can see that my optimal solution is going to be in this weird pentagon here, this region that I've sort of zoomed in there. Okay. Now, if you recall from before the holidays, the optimal solution is going to be near the corners of the feasible region. So either it's going to be here between equation 4 and equation 3 in that crossing point there, or it could be here between equation 2 and equation 1, or it could be here between equation 1 and equation 3, or it could also be there between equation 4 and the line y equals 2, or at the bottom right here between equation 2 and the line y equals 2. So we're not going to find all those solutions and then test them out. We're going to narrow down which of those vertices is going to be our optimal solution. So this is what the book does with a pencil and a ruler, and this is what I've done for you here. How do we narrow down what our optimal solutions are? We're going to plot the objective function. Now, if you look at the example, the objective function is p equals x plus 2y. So this is what I've got here in my example as equation 5, x plus 2y. Now, what do we make that equal to? Because we don't know what it's going to be equal to. That's what we are trying to maximize. So what we do is we're just going to give it a value, any value, so that we can plot it, okay? And then we're going to slide that objective function. So that's why I've got my slider here. You know where it says a equals 3.5? If you look at equation 5, I've taken the objective function and I made it equal to 3.5, which is at the bottom there. It's not even in my feasible region. But in the exam, once you got that first line, you can just slide the ruler, make sure you do it in a parallel fashion. Here, I can just use the slider, and as I make the objective function target value higher, you can see how the objective function moves up and down. So I'm going to try to see what could be the highest possible value. In the exam, you don't need to actually set a value. You just need to slide it and see what would be the highest place that you could put the objective function. Here, you can see that one of the optimal solutions would be the crossing point between equation 1 and equation 2. But I could still make my objective function a little bit bigger. I can still slide it up a little bit more, all the way there, where equation 1 and equation 4 meet, I believe. Is that equation 4 or 3? It is equation 3, sorry. So that crossing point between equation 1 and equation 3 is going to be where the optimal solution is going to be. So all you have to do is take equation 1, equation 3, solve those simultaneous equations, and if you look at the answer of this example on page 179, the optimal solution is 4 and 16 over 31, and the y-coordinate 5 and 19 over 31. Now, remember, we only want integer solutions, so I'm going to round up and down that solution that we just found. So I'm going to test the values 4, 5, 4, 6, 5, 5, and 5, 6. And then find out which of those coordinates gives me the highest value of the objective function. That's how I find the optimal solution. You also have to remember that even though one of those answers may give you the highest value of the objective function, you need to check that it satisfies the constraints, because maybe by rounding up you've actually gone out of the feasible region. So I hope that makes sense. I'm going to stop the recording now. Hopefully this will have worked. I will upload it. Please have a listen, have a check, have a play. Let me know if it makes any sense, and if it doesn't, just write something on the Google Classroom discussion page for the class, and we'll take it from there. Hope you're all doing great. I'm sure you are. Thank you, and hopefully we'll see you soon. Bye.